Once again, we are starting with Lewis structures to know more about a molecule. And this is kind of the first set of Lewis structures that we're going to use to answer the next question. You might see some questions where it just asks you to draw a Lewis structure, but it's very common that we need to use that to do the next thing. And one of those things is understanding the three-dimensional shape. So here I have two of the Lewis structures, not all three, because I wanted to zoom in a little bit more, of the Lewis structures for the nitrate ion. When we are looking at shape, we focus in on a central atom, nitrogen, for example, and look how many places electrons are around it. It is important that whether it's a single bond, a double bond, or we describe our bond order as some sort of decimal or fraction, it's still just a bonding region. There's three places with electrons around our central atom. Those spread out as much as possible, which is 120 degrees. And that ends up as trigonal planar. Around my phosphorus and my phosphorus trichloride, there's three bonds and a lone pair. That's four things. So they spread out to a tetrahedral electron geometry, but we want to focus on the molecular geometry. Trigonal, pyramidal, a triangle-shaped pyramid, and the angle's around 109.5, but a lone pair slightly pushes that together, making it a little bit less. Right here, this really looks nothing like the way the electrons really spread out. When we have three bonding regions and two lone pairs, that is 5 places they need to spread out. That becomes trigonal bipyramidal, where there's a thing above, there's a thing below, and then there's kind of, sometimes we describe it as like a belt that is a trigonal plane. That's like this, but there's something above and below my nitrogen, or in this case, my bromine. When I have lone pairs and bonds, the lone pairs actually go to whatever location they can be in that is the farthest apart. Because they repel more than bonding regions, in this case, they are not the top and the bottom, because then they would only be 90 degrees away from all of these bonds. So they end up being in the flat plane part of this. If you look at the pictures, that'll make a little bit more sense. But what this just comes down to is memorizing 3 bonding regions, 2 lone pairs is T-shape. For the expanded shapes, it's very rare that you have to know the bond angles, especially for the ones beyond just the electron geometry itself. Right here is a great example of how we can have multiple central or multiple internal atoms. Carbon has 1, 2, 3, 4 electron regions around it. All of them are bonding. That is tetrahedral. It's about 109 or 109.5, but oxygen is still inside our molecule. There's a bonding region, lone pair. So 2 and 2 gives me that bent shape that's about 109.5, but because of the extra repulsion from the lone pairs, it's a little bit less than 109.5. So it's very common that you could be asked about different central atoms and their shapes within a larger molecule.